Hi everybody, today let's talk about how to find the second derivative and what does the second derivative tell us. I hope that you still remember how to find the first derivative. Let's say if I have a function y equal to 2x squared plus 3x minus 1. If I ask you to find the first derivative, we will represent it by dy by dx. I hope that you still remember the process. You just bring the power go down here. So 2 times 2, you will get 4. Copy the x. Power, you have to minus 1, you will get 1. We don't have to write the 1 here. If you differentiate this, you will get positive 3. Differentiate a constant, you will get 0. So this is the first derivative, or we can call it gradient function. Because this is a function that we can use to find the gradient of the tangent of this curve at any point. So if the questions give us f of x, for example, 2x, f of x is equal to 2x squared plus 3x minus 1, we represent the first derivative by using f prime of x. So the same, 4x plus 3. Okay, so this is we differentiate y with respect to x. So what can we know from the value of dy by dx or from the value of first derivative? So these two are first derivative, just we represent it using different way. If you get dy by dx, you get the value of dy by dx first derivative positive. It means that when the value of x increases, the value of y increases as well. So this means that the gradient of the tangent is this way, going upward, having a positive gradient. X increase, y increase, x increase, y increase. Okay. So if you get the value of the first derivative dy by dx negative, it means that when the value of x increases, the value of y decreases. So it will be this way. X increase, y decrease. X increase, y decrease. Okay? Now, so today we are going to talk about the second derivative. It means that we have to differentiate it again. If this is dy dx, we differentiate again. We will write dy of dy by dx. So now we are differentiating the dy by dx with respect to x. But normally we do not write this way. We will just represent it by using this d2y dx squared. Okay, so if this is f prime of x, the second derivative, we will represent it by using f prime, double prime of x. They mean the same thing. They mean second derivative. If one prime only, this is first derivative, double prime here, this is second derivative. Okay, since we are differentiating dy by dx with respect to x, so it means that it tells us how does the value of dy by dx change with respect to x, right? d2y dx squared. If we get positive, it means that when the value of x increases, the value of dy by dx increases as well. It means that the gradient of the tangents increases as well. So this means that the graph is having a minimum point. Why? You see, this is negative, then it becomes 0, then it becomes positive, right? Keep on increasing the gradient of the tangent. So how about if you get negative? It means that when x, the value of x increases, the value of dy by dx decreases. So this tells us that the graph is having a maximum point. So you look at here, this is positive gradient, then it becomes 0, then become negative. Okay, so how about I use this one to show you, you will understand better. Okay, now I have a curve over here. F of x is equal to x squared plus 2x minus 1, right? So if I want to find the first derivative, f of x is equal to x squared plus 2x plus minus 1. The first derivative is f prime of x. Bring the 2 go down here, 2x plus 2. This is a gradient function. We can use this function to find the gradient of the tangents of this curve at any point. Here I have a few points over here. Okay, let's say I want to find the gradients of the tangent at point B. At point B, the point B is -2, -1. What we need to do is just bring the -2 go in here. 2 plus 2. This is -4 plus 2, and the answer is -2. It means that the gradient of the tangent at this point is equal to -2. Okay, let me show you here. You look at this equation. So this means that the gradient of tangent is -2. So how about if I differentiate it again? I do the second derivative. F prime of x is equal to 2x plus 2. If I differentiate it again, second derivative, I will get 2, positive. So it means that when x increase, the value of dy dx or f prime of x increases as well. So since this is 2, it means that when the x increase 1 unit, the gradients of the tangent increase by 2 units. Is this correct? Let's see. Now, the point B is -2, right? -2, the coordinate of point B, -2, -1. Now, the gradient is -2. Let me copy down first. Now the gradient is -2. So how about when the x increase 1 unit, become -1? The gradient become 0. Y equal to -2. We don't have x here. It means that y equal to 0x minus 2. So the gradient is 0. Okay, how about at point D? Now from -1 go to 0, the value of x increases 1 unit. The gradient become 2. So you will notice that when the x increases 1 unit, the gradient of the tangents increase by 2 units. So the gradient of tangent keep on increasing, right? So it tells us that this graph is having a minimum point. Same thing if I have another graph. Okay, now I have another graph. G of x is equal to -x squared minus 2x plus 1. Let me find the first derivative first. G prime of x. -2x, -2. So this is a gradient function. We can use this function to find the gradient of the tangent of this curve at any point here. So how about the g double prime? This is a second derivative, -2. So from here we get a negative value for the second derivative. We know that when x increases, the first derivative or the gradient of the tangent decreases. So in this case, every 1 unit, when the x increases 1 unit, the gradient of the tangent decreases 2 units. Okay, let's see correct or not. Oh. Okay, now I have 3 points over here. So every time the x increase 1 unit from -2 to -1 to 0. Let's see the gradient of the tangent. The gradient is 2. Then the gradient becomes 0. from 2 becomes 0, decreases 2 unit, right? So then the gradient become -2. So keep on decreasing -2. Keep on decreasing 2 units. Okay, so now you need to remember what does the information that we can get from the first derivative and what is the information that we can get from the second derivative. We will talk more about it in the next few videos. Okay, now let's look at a few examples. Okay, so this is what I told you just now. When the value of d2y by dx squared positive, the graph having a minimum point, or we can call it concave upward. When the value of d2y dx squared negative, it means that the graph having a maximum point, or we can say concave downward. Okay, don't misunderstand this. dy by dx square is not equal to d2y dx square. They are not the same thing. Okay. Now let's try this example. Okay, let's try this example. Given that the function y equal to 5x cubed minus 2x plus 4 over x, we want to find the dy dx, and this is the first derivative and also the second derivative. Hence, we need to determine the value of dy by dx and also the value of d2y by dx squared when x is equal to 1. Okay, let me copy first. Y equal to 5x cubed minus 2x plus 4 over x. So this I change it become 4x power 1. Now I can start to find the first derivative, dy by dx. This is a gradient function. It's a function that we can use to find the gradient of the tangents of this curve. 3 times 5, 15. Copy the x. Power always minus 1, you will get 2 over here. If you differentiate negative 2x, you will get negative 2. If you differentiate this one, negative 1 times 4, you will get negative 4. Copy the x. Negative 1, you have to minus 1, you will get negative 2. So I will change it become this. 15x squared minus 2 minus 4 over x squared. This is the first derivative. Then we want to find the second derivative as well. d2y dx squared. Okay, just look at this one. This is the first derivative. We are going to differentiate it again, but still using the same process. 2 times 15, you will get 30. Copy the x. 2 minus 1 is equal to 1. We don't have to write 1. If you differentiate a constant, you get 0. If you differentiate this one, negative 2 times negative 4, you will get positive 8. X copy. Negative 2 minus 1, you will get negative 3. The dx plus 8 over x power 3. Okay, so this is the second derivative. This is the first derivative. We have done this part. Now we want to find the value of dy by dx and also the value of d2y by dx squared when x is equal to 1. When x is equal to 1, dy by dx is equal to, okay, now we just look at this one, 15x squared, and we know x is equal to 1, so we are going to substitute the 1 inside here. 15 minus 2 minus 4, you will get 9. Okay, so how about the value of d2y by dx squared, second derivative? Now we are looking at this one, second derivative, right? When x is equal to 1, we are going to bring the value of 1 over here inside this functions. So it becomes 30 times x plus 8 over 1, also 30 times x, because x is equal to 1, right? So I'm going to write 1 over here. Just represent just change the value, the variable x become 1. So this is 30 plus 8, 38. Okay, so the answer is 38. Let's try another question. Given that y is equal to this, we want to express dy by dx squared plus dy dx in terms of x. Okay, let me copy first. Y is equal to 2x x squared plus 1. Here I'm going to do the expansion first. 2x times x squared, you get 2x power 3. 2x times positive 1, you get positive 2x. Now I will start to find the first derivative, dy by dx. 3 times 2, you will get 6. Copy the x. The power always minus 1, you get 2. If you differentiate 2x, you will get positive 2. Okay, so this is dy by dx. Now we are going to find the second derivative. It means that we have to differentiate this one again. d2y dx squared. Just now we differentiate the y function. Now we differentiate the gradient function. So this is a second derivative. But the process still the same. 2 times 6, you will get 12. Copy the x. Power you always minus 1, you will get 1. We don't have to write 1. If you differentiate the constant, you will always get 0. Okay, now we have the dy dx and also the d2y by dx squared. The question asks us to express this in terms of x. d2y dx squared plus dy dx. Okay, so this is equal to this, 12x. And this is equal to this, 6x squared plus 2. Okay, so we have done this part. Now the question asks us to solve this equation, d2y by dx squared plus dy by dx is equal to negative 4. This is equal to this, right? So it means that 12x plus 6x squared plus 2 is equal to negative 4. Okay, this one I think should be no problem. This is a quadratic equation. We just solve it as usual. Write the quadratic equation in general form first. 6x squared plus 12x plus 2. Bring the negative 4 over here. Plus 4 equal to 0. Now we just do some simplifications. 6x squared plus 12x plus 6 is equal to 0. So now you can start to use your calculator to help you, or if you don't want, you can reduce it, make it become smaller, the number here. Just divide the whole equation by 6. When the number becomes smaller, it's actually easier for us to do the factorizations. Okay, now we can do the factorization easily. This one I hope that you still remember. If you already forgot about this one, you can go back to your Form 2. Form 2, there's a chapter, right, talking about the factorization and also expansion. Okay, go back to that chapter and do some revision on it. So this is 1, this is 1. Okay, correct. This is positive, positive. Okay, let me double check. Okay, correct. So x plus 1 is equal to 0. X is equal to negative 1. Okay, so that's all for this video. I hope that you understand better about the first derivative and also the second derivative. We are going to talk more about the usage or how to use the second derivative to help us to determine whether a given point is a maximum point or minimum point. Okay, see you next time. Bye bye. Thanks for watching.